checking all sounds up. Okay, just check sounds up and fine. See how sound is. Yeah, I think sound's there. Need to worry about that. Let's get a timer. Right. Oh, right, cracking. So, I think we're ready to just get started. So, yeah, welcome back tonight. This is the second part of going through Boot.dev's OO object-oriented programming. I got a feeling we had to start later tonight, various reasons and stuff. Oh no, I lost my streak. Never mind. Smack them all red. Make sure we're refreshed. So yeah, we're going through the second part of this course. We've only got 2 chapters left: inheritance and polymorphism, and then I had to start late tonight. But if we get through that, then it means next week we'll be building again. So we're building asteroids. Should be kind of really cool. I'm excited for that. It's going to be 18 lessons, is it? Yeah, so 18 lessons. So we're here for object-oriented programming. So without further ado, 1 second, one last check of things. Yep. Okay, we good? Let's roll. So, inheritance. This is the first lesson of the chapter. So, inheritance. We've made it to the holy grail of object-oriented programming. Inheritance. Non-OOP languages like Go and Rust allow for encapsulation and abstraction features, as nearly every language does. Inheritance, on the other hand, tends to be unique to class-based languages like Python, Java, and Ruby. What is inheritance? Inheritance allows one class, allows one class, the child class, to inherit properties and methods from another class, the parent class. This powerful language feature helps us avoid writing a lot of the same code twice. It allows dry, don't repeat yourself, up our code. Dry up our code, right? As we learned about dry code, be careful. Keep it a little bit damp sometimes. Syntax. Here, cow is a child class that inherits from parent class animal. The cow class can reuse the animal class's constructor with the super method. Super allows the child class to call methods and constructors from its parent class. In this case, the init. So, animal has definition init, self number of legs, class cow animal, definition init, self number of udders, super init for, call it the parent constructor to give the cow some legs, and then set cow specific properties. Okay. In assignment, in the Age of Dragons, all the archers are humans, but not all humans are necessarily archers. All humans have a name, but only archers have a num arrows property. Complete the archer class. It should inherit the human class. Its constructor. It should call its parent. Its constructor should call its parent constructor. Then also set unique num arrows property. So we'll do that. So don't touch above this line. So the archer one takes human. Yeah. Arrows have a property. So in it, pass. We're going to do that. We're going to do super duper. It's going to be underscore in it. Whoops. In it like this, and then name. So just pass name to it again. Do self dot num arrows equals num arrows. Run. Passed. Submit. Boom. Easy peasy. When should I use inheritance? Inheritance is a powerful tool, but it is a really bad idea to try and overuse it. Inheritance should only be used when all instances of a child class are also instances of the parent class. When a child class inherits from a parent, it inherits everything. If you only want to share some functionality, inheritance is probably not the best answer. Better to simply share some functions, or maybe make a new parent class for both the classes can inherit from. All cats are animals, but not all animals are cats. And cheese is definitely not a cat. It makes sense for animals to inherit from plants. It makes sense for cats to inherit from animals. True. Animals and plants might inherit from a class called organisms in objects, trees, organisms. Okay, inheritance hierarchy. There's no limit to how deeply we can nest an inheritance tree. For example, a cat can inherit from an animal that inherits from a living thing. That said, be careful. New programmers often get carried away. You should never think to yourself, well, most wizards are elves, so I'll just have wizard inherit from elf. A good child class is a strict subset of its parent class. Example of this with private properties. A child class cannot simply access a private property of its parent class. It has to use a getter. For example, the wall has its own height, and it has a getter for get height, and the castle inherits from a wall. I guess it makes sense. And it has its own self, so it has its own height, has towers, and it has self. But it sets the height of the wall with the castle height. Get tower defense like that. So let's add a new game unit, crossbowman. A crossbowman is always an archer, but not all archers are crossbowmen. Crossbowmen have several arrows, but they have additional method, triple shot. So do not touch above this line. Triple shot. Add a use arrows self-num method to the archer method of the class. To the archer class. Okay, so... Oh, sorry, you got it. Use. It should remove num arrows. If there aren't enough arrows to remove, it should raise a not enough arrows exception. So if self dot num. So if I guess if num is greater than self dot num arrows. Then I've forgotten it already. What was the thing to throw an exception? Raise. No, it wasn't. It was like raise. I'm sure it was raise, wasn't it? Not raise. Let me try and think. Let me try and remember chat. Not raise. No. Exception. No. There was a keyword. What was it now? It wasn't raise. I forgot the word. But then it'd be. Hold on, we have to look it up. I've forgotten what it was already. Exceptions. I'm going to be really annoyed when I see it. No, not that. Raising exceptions. It is raise. Did I output that? Oops. Raise exception. Maybe it's just not the all complete. I was right. Else blah blah blah. Self dot. Let's copy that. Self dot num arrows minus equals num. The crossbones class constructor. Okay, so we've kind of done that. Failing at the minute. The crossbones class constructor should call its parent's constructor. Okay. Super. If I can spell. Super. Yeah, super dot underscore init underscore an archer, so it's going to need a human. So name and num arrows. So name num arrows. Do I need to pass self to it? Nope. The crossbowman's triple shot method choose 3 hours. The crossbowman's triple shot method takes a target as a parameter and returns was shot by 3 crossbow bolts. Where it's the name of the human that was shot. Okay, self target. I guess we're going to try and self dot use underscore arrows. And we're going to press self dot underscore num underscore arrows. And if it doesn't thingy that, so we're going to do print an F string like that. Try that. Okay, let's see what we got going on here. Got something wrong. So first one, so creating an archer named Will with the archer 1 arrows, creating a crossbowman named Darren with the crossbowman 4 bolts. Crossbowman object has no attribute crossbowman num arrows. I got the wrong end of the stick. Oh, I need to use the gear. Whoops. Silly me. Right. Yep, still failed. That's not it. Unexpected exception can only concatenate string, not non-type to string. Target. Oh, I've forgotten the easy way to like print out. What's the easy way to print out everything for? Where is it? Python print. Well, that does work. Hold on. Why is it falling down? So, expected. Will the archer was shot by 3 crossbow bolts? So that unexpected obsession can only concatenate string non-typed. Or if I just don't handle the exception, I guess. Oh. Is it just because I'm not returning it? Okay. I got 2 passing, 2 failing. So, will the actual shot expect to remain at arrows actual 0. Oh, I'm a big dummy. Should just be 3, shouldn't it? Or it should be... Yeah, 3. Where does it fail? So, create an archer named Lara the Archer with 3 arrows. Create a crossbowman named Marcus with the crossbowman with 2 bolts. Not enough arrows expected. Exception, not enough arrows, but no exception occurred. Oh, I guess we don't need to. It's because we're handling it here, so. There we go. Just had to let it fail. Just had to let it fail. Actually fail. Fair enough. Okay. So inheritance review. Good hierarchy. So real estate, residential house. Bad hierarchy. Rental, duplex, cheap. Example of inheritance code. Real estate. It's got self-location. Residential is a child of real estate. Has location to pass. Bedrooms. And then house, residential. House is a type of residential property. Blah blah blah. It takes location, bedrooms, and yard size, and applies all these. Imagine dog inherits from canine. The class uses super to call the constructor of the boop class. The dog class uses super to call the constructor of the canine class. That one. How many levels deep can an inheritance hierarchy be? Infinite. No reason to stop it. Nobody said, no way, Jose, you can't do that. No chance. No, silly Bob. No. You do as many as you want. Okie dokie. Right, multiple children. So far we've worked with linear class inheritance, but usually inheritance hierarchies form trees, not lines. A parent class can have multiple children. So, character, elf, human, dwarf. Noldor, Sindar, Númenorian, Gondorian. Dwarves are just in the league of their own. Usually inheritance hierarchies form trees, not lines. Multiple children, yep. Assignment. The archer class should inherit from hero. Ensure the following requirements from the game designers are complete. Archer should inherit from hero. Yep, so it does that. Archer should shout up the hero's name and health. So it does. Set a private number of arrows variable that can be passed in as a third parameter to the constructor. It already is. Create a shoot method. So self dot do it like the other ones, I guess. Like so, num arrows equals num arrows, and then create a shoot method that takes a target as an input. Target as an input. If there are no arrows left, raise a not enough arrows exception. Otherwise, remove an arrow and deal 10 damage to the target hero. So, I guess creation method takes the target. If there are no arrows left, so okay. So if self dot num arrows self dot num arrows is less than or equal to 0, then raise exception. Not enough arrows. Else. What was it? Remove an arrow and deal 10 damage to the target hero. So self dot num arrows minus equals 1, and then target dot what was it? Take underscore damage 10. Run that. Passed them all. Bushka. Multiple children. Assignment. Let's extend the hero class by adding a second child class, the wizard. Wizard heroes are more powerful than archer heroes. But it casts spells at other heroes instead of shooting them, and casting does 25 damage instead of 10, but also costs 25 mana. Fulfill the following requirements. Wizard should inherit from hero. Done. Wizard should set up the hero's name and health. So what does hero do? Private mana, so super dot underscore init underscore name health, and then self dot underscore mana. Create a cast method, that takes a target hero as input. There's not enough mana left. Raise not enough mana. Exception. It's been a long day. Otherwise, remove 25 mana from the wizard and deal 25 damage to the hero. Okay, so shoot, cast. So whoops, what am I doing now? So if what are we saying? So fix a hero. So if self dot underscore mana is less than 25, was it? Then raise exception else. And what are we saying? Otherwise remove 5 mana. That's equals 25, and then self dot target dot deal damage. Take square damage 25. Run that. Whoops. Whoops, I forgot the brackets. Dum me. Easy peas. These are all kind of like the same questions at the minute, but multiple children quiz. It is more common for an inheritance tree to be wide than deep. Deep inheritance tree, wide inheritance tree. So there's an organism, an animal, fella, and then dragons can be drakes, wyverns, hydras, and druks. Never heard of druk before, but sounds kind of cool. You likely won't see an inheritance tree with a base class of organism leading through a chain of 4 subclasses to cat. If you do, run. Why are inheritance trees often wide instead of deep? As we talked about earlier in good software, a child class is a strict subset of its parent class. In a deep tree, that means the children need to be perfect members of all the parent class types. That simply doesn't happen very often in the real world. It's much more likely you'll have a base class that simply has many child classes that are slightly different variations of the base and siblings. Inheritance trees are often wide than deep. A class must have at least children, and at most children have at least. Didn't have to have any. 0 to infinite. No rule for that. Don't lie. 4 left on this, and then we'll be doing polymorphism. It's a fun word to say. Hope you're all following along and having fun or learning something as you're doing stuff. Don't forget to go and sign up if you are learning back-end development. Sign up for Boot.dev. Parts of it are free. I have to double check how much of it is free and stuff, but it is worth every penny. You've got the thing to spend on it. So if you want to learn, definitely go and give it a try. I'll be doing a full review when I finish all the modules and everything across Boot.dev in the end. So in Age of Dragons, there are orcs, humans, goblins, dragons, etc. All those different creatures are called units. At the moment, the only specific to a unit is that it has a position on the game map and a name. Dragons, a specific type of unit, can breathe fire in a large area, dealing damage to any units that are touched by its fiery blaze. The game grid. Our game map is just a Cartesian plane. Whoops. So assignment: complete the units in area method and the dragons breathe fire method in area. So we'll tackle this one by one. We've got unit and we've got dragon. This method has 4 parameters: x1, y1, x2, y2. The coordinates x1 and y1 represent the bottom left corner of the rectangle. x2 and xy represent the top right corner. Determine if a unit is within or on the boundary of this rectangle. Use the unit's position coordinates, position x and position y. If the unit's position falls inside or on the edge of the rectangle, the method returns true, otherwise it's false. I kind of read that without actually like taking it in and stuff. My brain's going a little bit. If it's proper x1, blah, blah, blah. Top left of the bottom left corner, top right corner. To determine if a unit is within the boundary range of the rectangle, use the unit's position coordinates, position position x and position y. Okay. So it's past boundary, okay. And they said if the unit's position falls inside or on the edge of the rectangle, the method returns true, otherwise returns false. So I'd say we'll just make two variables for this, so like within x bounds. There's like variables in Python. Within x bounds, within x area actually. Within x area equals if x1 actually no, do it the other way around. So self dot position underscore x is greater than or equal to x underscore 1, and self dot position underscore x is less than or equal to x underscore 2. I basically copy this, do the same for y. I'm just going to have to do it like the old fashioned way. And then if within x area and within y area, then return true. Else return false. Okay, I think that's right. We'll double check and see in a minute. We'll see in a sec. Breathe fire. This method causes the dragon to breathe a swath of fire in the target area. The target area is centered at XY. The area stretches for fire range in both directions inclusively. For each unit in the units list, append that unit to a list if the unit is within the blast radius. Return the list of units hit by the blast. Example: fire breath hitting a unit. Example above uses fire range of 1, centered at 1, 1. So area of effect 0, 0, 2, 2, unit position 1, 1. Okay, so breathe fire. This method causes the dragon to breathe a swath of fire in the target area. Target area centered at X, Y. The list of units append. Hold on. The target area is centered at X, Y. The area stretches for fire range in both directions inclusively. For each unit in units list, append that unit to a list. If the unit is append that unit to a list. If the unit is within the blast, return the list of units hit by the blast. So okay, so whoops. So we'll have what do you call it? List within blast equals empty array. I've not forgotten that already, I'm pretty sure. And then I guess for can't remember it. So for unit in units, can I do that? And then we say self dot in square. Alright, let's get back up online. Let's see. My computer crashed, so that wasn't fun. Oh no, not timed out, did it? We're back live on Twitch. We might have lost it on. Okay, X is over. X is over. Let me just see if everything's back for YouTube. Yeah, I think everything's back. Can you hear us all right, Bassam? Just checking everything. I think the stream to Twitter's gone, but looks like everything's back. Will awesome all as well here. Cool. Yay. So we back. Cool. Right. Let's carry on. Yeah. Computer died. It's happened. It doesn't happen very often. It's happened a few times, but I'm looking at getting a separate machine to do the coding and stuff versus like the machine that's just streaming. I don't know if that'll help. It should do. It's not. Yeah, it's a pretty decent computer, so like I'm not sure why it's struggling. But anyway, we'll carry on. So we were just in the middle. We were just about to get started with the breathe fire part. So Boot.dev is so good, guys, that like all of this was just saved. Like I didn't hit save. It was it's just saving as it goes along and stuff, so props to that. That was really good. Okay, so we're just looking at the basically looping over the units, and then we were going to send to in area x1, x1, y1, x2, y2. I don't know what the thing of like units is. I hope we can kind of just pass it to it. I'll just try that, to be honest. It wants like separate arguments and stuff. I forgot if there's like a spread thing you can do like that or something. Let me look it up again. So spread like arguments. Arguments. Personal arguments. Come on, that's not it. It's not one of those. I'm just gonna try it. So like basically we do that for that. So that will return true or false. So if that is true, then we want to list within blast rage dot append the unit. Return list use hit by blast, and then all we're going to do is like after all that, we just want to return list within blast. Try run that. It's probably going to have a whole bunch of problems. Self in unit errors requires three required positional arguments. So yeah, that's the thing. So it's going to be. I guess I'm just going to have to do it like the long-winded way. I'll try and make it a little less cumbersome though. I can't remember if there's like a decent way to like spread arguments onto it. Unit dot oops unit dot unit dot unit object has no attribute for x1. So if we just print units, is there a different print mechanism? Print Python print list. Guess we just print it in here. So print unit, just see what it is. Object main unit. Object. Is there no easy way? Python print object. It's got to be a way to just simply print the object without having to do all the things. Like something crazy. There's got to be something built in, right? What? Reject all. Thank you very much. None of that. Yep. Print all attributes and objects in Python. Use the dir method. Okay, I'll try that. Oh, I'm a dummy. Unit tells me what it is here. Oh, I'm silly. So unit in unit, so unit in area x1, y1. X and y. Okay. Suppose we need to calculate the fire range, so that's the part here. So I guess we need so it's going to be x underscore 1 equals x minus self underscore something like that, and x2 is going to be that plus then y it's going to be plus that. So not quite. Stretches for fire range in both directions inclusively for each unit. So I think this is right here stuff. So yeah, if it's equals units depends. So it caught Baran is so the testing Dragon Draco at 2-2. And then the one that shouldn't be in there is Baron, so -6, 5. Breathing Fire at 2-3. Should never have hit him. Why did it hit him? Let me look at. So we've got I guess self dot. Baran, so -1. Just follow it through. I think that's all correct. So this part, we're saying the unit name barren. So this is the one that fell into true. Where it's x1 is -1. 5, 0, and 6. How does that fall in? Tag area centered at x, y. The area stretches for by a range of both things. Area. So we self dot position x and then self dot position y. It's going to be at 2, 2. Tag area centered at x, y. The area stretches for in both directions inclusively. Unit. I think I've messed up something with this part. So we're saying that x1 that's going to be fed into here. So self in area, and you're going to pass it. It's got this. The unit's going to get its own position, and you want to say within area x. So the methods for parameters x1. The coordinates x1, xy represent the bottom left of the corner of the rectangle, top right. Yeah. Okay, so that's right. So you need to pass the areas x1, x2 and stuff. And the area is going to be x minus the fire range inclusive. So the area, it starts at 2, 2. The fire spread, the fire range is 3. So 2 minus 3 is minus 1. Plus is 5, obviously. And then 2 minus 0. Hold on. That should be minus 1 as well. Is y. Y. We don't really care about that, do we? That's not right. X, Y, hold on. Right, that makes more sense, okay. Doing silly stuff. Minus 6 and 5. Oh, such a dummy. Oh, simple things, people. It has been a long day. I was referencing self, so it's always referencing the initial unit. So there we go, fixed it. Way, God, we got there, and it's 10 o'clock, crikey. So we've got 3 left. Got 3 left and done for the day. Okay, 3 left, and then brain needs to chill out. Been doing too much. And we will get this done within the time limit, so it does not matter. We will finish this. Because, yeah, we'll get polymorphisms. So we've got 3 left and then polymorphisms, and polymorphisms shouldn't be that hard. Unless these are going to be a real pain in the neck like that one. Dragons. We created a lot of classes in this course. Now let's write some code that uses them. Let's have ourselves a little dragon fight. Complete the bottom half of the main function using 2 for loops. Don't touch above that. Okay. In the first for loop, describe all the dragons starting with the first dragon in the list and ending with the last dragon in the list. So for dragon in dragons, then we want to describe dragon. Okay, in the next for loop, have each dragon breathe fire at coordinate x equals 3 and y equals 3, passing all of the other dragons, not the one breathing fire, as the In the next for loop, have each dragon breathe fire at coordinate x3, y3, passing all of the other dragons, not the one breathing fire, as the unit's parameters so we can see if they get hit. Okay, so for dragon, I can't type. It's going in dragons. Of each dragon, so dragon, what is it? Breathe fire. And self-inflicted units, so oops, not 4. And it's going to be 3, 3, and I'll figure it out in a second, but I need to basically just get everything but the one that's currently being done, and see if they can get hit, passing the dragons in ascending index order. For example, when blue dragon breathes fire, it should breathe fire on the other dragons in this sort of example output. Bit tricky that. I fluffed something up. Python traceback line 5, line 59, line 15. Object has no attribute breathe fire, so dragon. Dragon. Dragon object has no attribute breathe fire. If I click that, that'll take me, you know. Dragon breathe fire. I spelt it wrong. Oh, I have. Oh, what the heck? Red, blue. How does it do that? Yeah, I didn't think that was right. So green dragon breathes fire at 3/3 with range 1. Red dragon is hit by the fire. Blue dragon is hit by the fire. And red dragon breathes fire at 3/3 with range 2. So what's wrong with that? Zero zero 2 2 4 3 5 1. So basically, I think the thing that's missing here is that we want to like loop over it. Yeah, shouldn't you exclude the dragon from breeding fire? Yeah. I'm trying to think what's the simplest way of doing that. I think, to be honest, I was just going to look something up, but I think, can't we just, I've forgotten in Python, like, so can't we just like remove it from the list? If, can I delete from the list, like without an index or something, or? I guess it kind of modifies it, so like index into lists. Yeah, not that. I just want to basically slice the list. Like, I need the index for that though. I just wondered if there was a way I could like remove it. So is the end of it. Delete. I'm sure I did this like last time. So like delete dragons. Oops, I can't. And then dragon like that. Will that work? Nope. This needs to use me into a slice and not dragon. Okay. I guess I've got to do just like a for in. You can check if statement. Hold on. I just want to get a slice of it. List operations. I think I want to slice it, but don't have to do the index. Yeah, what's a clean way of doing this? Well, if we call this like other dragons equals dragons. So other dragons is going to be this list without the current dragon. Get index. So we like index into it easily. Like Python get list entry by value. Index returns the index of the element in the list, and you can use index together. Index banana. Try it that way. So I guess current dragon index equals dragons dot index and then dragon, and then if we do dragons, and then we do other, it's like delete other dragons and then current dragon index. Can I do that? kind of. Yeah, deletes off of the thing, so we need to like other dragons. Lists. Copy. Is there a way do I need to like copy the list? Python copy list. Oh, list.copy. Okay. So copy. I think that's it. Yay! Let's see what their solution was, because I'm curious as to how inefficient like mine was. So they did foreign length range. They did kind of just the same thing. This one, they did, yeah, they did the same thing. So like without, they used the range thing. Dragon's eye, yeah. Other dragons copy, delete other dragons. Yeah, same difference, I guess. So yeah, both work. Figured it out. Almost done with this one, and then one more tonight, and we'll be done. Yeah, we've got a good like half an hour or something. Rectangles. You discovered that to properly calculate army formations in the game, you need to be able to get the area and perimeter of squares and rectangles of various sizes. Challenge. Finish implementing the empty methods of rectangle square classes. All squares are rectangles, but not all rectangles are squares. Due to inheritance methods of square, the square class should only need to implement the init method. Bunch of stuff. Okay, so the square class should only need to implement the init method. Okay, so super duper duper dot underscore units underscore like that, and then we're going to pass it length. Length and length. Okay, so then for this init, we're going to do self dot length. I suppose we don't need that. We don't need private things. We just want to do length equals length, and then self dot width equals width, and then get area. So we're going to do return self dot length times self dot width, then get perimeter. Return self dot length times 2 plus, and we'll put this in brackets, plus self dot width times 2, and that, boom, first hit, first try. Oh my goodness, please don't let this be the long one. Right, caravan. I gotta get to the next section for the end of the night. Come on. Siege weapons, battering rams, catapults are special units in Age of Dragons. Let's write the logic for how they move around the map. Complete the siege, battering ram, and catapult classes. Siege class. Complete the constructor accepts 2 parameters in order and sets them as instance variables with the same name. Siege class, complete siege, battering ram, and catapult classes. Siege class. Complete the complete the constructor accepts two parameters in order and sets them as an instance variables with the same name. So self dot max speed equal max speed. Self dot efficiency equals efficiency. Okay, complete the get trip cost method. It calculates the cost of a trip and returns it. The following for calculating cost is this. So return. Okay, easy. It costs food to move the siege weapons. Those things are heavy. Leave the get cargo volume method empty. Use the word pass keyword. Child classes will override this method. Battering ram class. Complete the constructor. It calls the parent constructor and sets the extra battering ram only instance variables as member variables. It calls parent and sets the extra. So super super like that dot init like that, and then it's what does it take? Max speed and efficiency. So max speed efficiency, and then the other stuff like load weight. So self dot load weight equals load weight, and then self dot bed underscore area equals bed area. Okay. Get the get trip cost. So get trip cost uses the parent method to calculate the cost of the food for a trip plus the extra cost of carrying a load. The following for calculating the cost is this. So get trip cost. So the formula is this: base cost to calculate the cost of food for a trip. Base cost. Method uses the parent method to calculate the cost of food for a trip plus the extra cost of carrying a load weight. So base cost. So it's going to be self dot get trip cost. Like that. Okay, I think that's that. That's right. The get cargo volume method calculates and returns the cargo capacity in cubic meters to get the volume of the battering ram's bed cargo area. Multiply its area by its depth, which is always 2 meters. So return calculus method calculates return and returns the cargo capacity in cubic meters to get the volume of the battering ram's bed cargo area. Multiply its area by its depth, which is always 2 meters. Area. Okay, so self dot bed area times by 2. I think that's right. Catapult class. The constructor calls the parent constructor and sets the extra catapult only instance variable as a member variable. Okay, so shoopity duper. Super dud hoopity doop. And it's max speed efficiency. And it's got a cargo volume is its own thing. So self dot, I'm not going to type it out, it's a long one. Self equals that. And then do not override the get trip cost method. It's inherited to the parent class. The get cargo volume method just returns the cargo capacity of the catapult. This is already set by the constructor. So return almost one shot it. Right, wait, it failed. So get trip cost, whoops, I forgot to give it stuff. Distance and food price, wasn't it? So distance and food price, distance, food price. That fix it? Oh, I almost, what? I still logged in? Refresh. Uh-oh. Maximum recursion depth exceeded? The heck? So there's something up with this. I didn't quite understand this. Like base cost. What's base cost? Just this? I have to do this again? Right, it passes. Let me just check like what that's meant to be doing. Yeah, I got that right. I must. Oh, that's how you do it. I didn't realize it was like that. Whoops. I suppose that's what that means here. So if it's doing like that. Big dummy. I was doing self dot that. Right. Oh well. Right. I know for next time. Okay, I understand that now. That was a Pythonism that I didn't get. Okie dokie. So how many we got left? Blimey. Hope this goes a little bit faster. What is polymorphism? While inheritance is the most unique trait of object-oriented languages, polymorphism is probably the most powerful. Polymorphism is the ability of a variable function or object to take on multiple forms. Poly equals many, morph equals form. For example, classes in the same hierarchical tree may have methods with the same name but different behaviors. Let's look at a simple example. So class creature, define move self, print the creature moves. Class dragon creature, define move self. Creature, define move creature flies. The dragon, kraken child classes are overriding the behavior of their parent class's move method. We're going to. How is this different? Hold on. We have in the same hierarchical tree, we have methods with the same name but different behaviors. Okay, dragon, kraken child classes are overriding the behavior of the parent class's move method. Creature moves, the dragon flies, the kraken swims. We're going to build hitbox logic for our game step by step Starting with a simple rectangle, complete the init method. Configure the class to have properties matching the variables passed into the constructor in this order. So self dot x1 equals x1, and self dot x2 is x2. Self dot y1 equals y1. Self dot y2 equals y2. Easy start. Get edges. Oh, blimey, I do hope this I can get it through tonight. I don't want to carry on next week. This one. Remember that with normal units, we were checking if their XY point was within a rectangle, the dragon's breath, to see if they were hit by the fire. With a dragon, because they're so big, we're going to check if the dragon's body, a rectangle, is within the fire, also a rectangle. The image below contains an example of fire breath hitting a dragon. In the assignment, to fire breath in the dragon's body. The next assignment will be writing the overlap method itself, but first you're going to write a method to find the edges of a rectangle. The coordinates have now been made private members. We added 2 underscores to them, so we need to write getter methods to access them. First, let's set up some helper methods to find these edges. So write the following methods, what they should do, self-explanatory, given by their names. Okay, so get left x. x1 turn self dot underscore x2 turn self dot y1 turn self dot underscore y2 and then run that. Whoops. Did that. Remember that x1 or x2 could be the left x based on its value on the Cartesian plane. Same goes for y values. You may find Python's built-in min-max functions useful if you'd rather not use comparison operators. I've forgotten how they work. Min, what's the example? Return the smallest item in the iterable or smallest of the 2 arguments. Okay. Get left. So I guess we could do min, and then not quite. So expecting actual, did I get my thing mixed up? Min max x1 y1 y2. Well, whoops. Max min. Bingo wingo. Assignment. So let's write the overlaps method. It should check if the rectangle overlaps the given rectangle rect. Return true if this rectangle overlaps any part of rect, including just touching the sides, or false otherwise. Here are 4 conditions that must be true if this rectangle A overlaps or touches rectangle B. Don't touch below this line. Okay. So A's left side is in or on left B's right side. A's right side. So self. Okay, so it should check if the rectangle overlaps with the given rectangle rect. Return true if the rectangle overlaps any part of rect, including touching the sides, or false. So overlaps left side overlaps right side overlaps top side overlaps bottom side. Yep, so then if overlaps or so right side, so overlaps left side, so if self dot get left x should check if this rectangle overlaps a given tangle rect this rectangle A. So if the left side is on, so if the left side is on or to the left of B's right side, so if the left side is it's less than or equal to rect dot get right x, then overlaps right side, so then self if get right side, so get right x is on or to the right of is greater than or equal to left side, and then basically that. So like get so if A's top side, so top y is top side is on or above B's bottom side, so greater than or equal to bottom y, and the reverse of that, so equals top y bottom y is less than or equal to top y. Try that. Dang it, almost got it. Okay, so the first one passed, so rectangle not 4 and the rectangle there, so overlap expected is true and the actual overlap is true. Expected overlap false, actual overlap false. Whoops, that was not the play. is on or below B's top side. So overlaps left side. So left side is on or left of B's right side. So this one. So I guess print this. So in the one that fails, overlaps left side, that is true because 0 is less than the get right one, but it shouldn't be true. If A's right side is on, so if A's left side is on or to the left of B's right side, so the one that failed, 2, 2. Oh no, not the error boundary though. It's gotta be equals like that, isn't it? How many are wrong if I do that? One failed still, so it still fails the Oh, it's not that one. It fails though. Actually, it's it's not the boundary one. So top side. So left, right, top, bottom. Top Y is greater than or equal to bottom Y. Greater than or equal to top Y. No, it's not like that. It's got to be like that. What's the condition that it's fluffing up on? It's only one fail. It's so annoying. It's that part. You know, I don't want to be on this too late, so I'm going to do one thing I haven't done the whole thing, which is I'm going to just get the solution because it's a real weird little edge case I'm just trying to figure out. So I'm going to just view it for the sake of it. Yeah, okay, that's fine. Okay, so self get left. C minor response. I'm pretty sure it's kind of the same. I put it as or. Why have to be and? Or less than get right. That's what I did. Get right. Get left. All the comparisons are like the wrong way around. Get top Y. Get less right. So is it because? Hold on. So I was right with how I was doing the logic. That's a less than like that. And then what's wrong with that? Because it's ors. Needs to be and. Whoops. And here for conditions must be true if the rectangle overlaps. That must be true if the rectangle A overlaps or touches B. Always read the question. We move. Let's get this done tonight, hopefully. Crikey. It's almost 11 o'clock. Bring it together in the Dragon class. Let's bring all we've done together in the Dragon class. The Dragon class should override the units class in area method. Instead of checking if the center position of the dragon is in the given area, we'll check it if its big dragon body overlaps with the given area. Methods in parent classes often use pass to signal they should be overridden in child classes. To override, create a method in the same name in the child class assignment. So first, complete the dragon's constructor. The dragon needs one more private member of hitbox. The hitbox is a rectangle object you've been provided with the height, width, and center position for the right, or the blah blah blah. Dragon's constructor. Okay, so then needs one more private data member, so like that equals want it to be a rectangle object, so we're going to be a new rectangle like that, and it's going to be x1, y1, x2, y2. So x1, y1. Okay, so position y minus height, and then position x plus width, and then finally position y plus height. Okay. You don't need a new keyword. Still fails, that's fine. We do the syntax right. So okay. Next you'll need to override the in-area method that the dragon class inherited from unit. In the dragon class in-area method, create a new rectangle object with the given corner positions. And use the rectangles overlaps method to check if the dragon's self the hitboxes inside this method should return a Boolean value. So create a new rectangle object with the given corner positions. So we'll call this given area equals a rectangle. Rectangle. I'm going to pass all these bad boys like that, and use the rectangles overlaps method to check if the dragon self hitbox is inside it. This method should return Boolean. So if self dot area dot overlaps and then we get self dot hitbox, and then return true, else false. Does that work? Almost. Yeah. What did I do wrong? Pass, fail. Dragon position at 0055, area corners 4051, expected in area false, actual expected in area true. So let me check the in area part. So in area part in the dragon class in area method, create a new rectangle object with the given corner positions and use x1, y1, x1, y2. Yep. Okay. x2, y2. Given area and use I think it's probably this. Hitbox position x height. Oh, hold on. Oh no. There we go, just had to half it. See if they had a more elegant solution. Half width, yeah, they kind of do the same thing, basically, same thing. Oh, let's move. Come on, we want to finish this tonight. Take a look at the Greek roots of the word polymorphism. Poly means many, morph means to change or form. Polymorphism is in programming is the ability to present the same interface, function, or method signatures for many different underlying forms, data types. A classic example is the shape class that rectangle, circle, triangle can inherit from. With polymorphism, each of these classes will have different underlying data. The circle needs its center point coordinates and radius. The rectangle needs 2 coordinates for the top left, top and bottom right corners. The triangle needs coordinates for the corners. By making each class responsible for its data and its code, you can achieve polymorphism. In the shapes example, each class would have its own draw shape method. This allows the code that uses the different shapes to be simple and easy. And more importantly, you can treat shapes as the same even though they are different. It hides the complexities of the difference behind a clean abstraction. This in contrast to a functional way of doing things where you would have to have separate functions to have different function signatures, draw a rectangle, draw a circle. Wait, what is a function signature? A function signature or method signature includes the name, inputs, and outputs of a function or a method. For example, hit by fire in the human and archer classes have identical signatures. Both methods have the same name but take 0 inputs and return integers. If any of those things were different, they would have different function signatures. Here is an example of different signatures. The archer's class's hit by fire method takes an input damage which is used to calculate the new health. This is a different signature than the human class's hit by fire method, which takes no inputs. Calling two methods with the same signature should look the same to the caller. Same inputs none, same name, same outputs a single integer. When overriding methods use the same function signature. If you change the function signature of a parent class, when overriding a method, it could be a disaster. The whole point of overriding a method is so that the caller of your code doesn't have to worry about what different things are going on inside the method object types. Poly means many, and morph means whoops, right at the top, change or form. The main benefit of polymorphism is to write few lines of code in your class, to hide the differences between subtypes from users of your code, to give users of your code different function signatures for a single method, to enclose to enclose the complexities of your classes behind get methods, to hide the differences between subtypes from users of your code. Yeah. Another one, methods on different classes can have the same signature. True. Okay, another one, definition add, AB, return AB, and have the same signature. False. Different number of arguments. It's a good idea to use blank when overriding a parent's method from a child class. Same function signature. Oh, how many we got left? Overload review, overriding, building a class. Come here. Right, operator overloading. Another kind of built-in polymorphism in Python is the ability to override how an operator works. For example, the plus operator works with built-in types like integers and strings, like this and this. Custom classes, on the other hand, don't have any built-in support for those operators. Type error, unsupported operand types, point and point. However, we can add your own support. If we create an add self other method in our class, the Python interpreter will use it when instances of the class have been added with the plus operator. Here's an example. Now when P1 and P2 is executed under the hood, Python interpreter just calls P1 add P2. Assignment. In Age of Dragons, players can upgrade their weaponry to make crafting simple for other developers. We'll use operator overloading on the sword class. Note how the test suite attempts to use the plus operator to craft the swords. Overload the operator plus operator to craft the swords. Add this method to the sword class. It's already there. It will be used to craft two swords together to create a new sword. Return a new sword instance. Sword type is just a string. Sword type is just a string of one bronze, iron, and steel. If two bronze swords are crafted together, return an iron sword. If two iron swords are crafted together, return a steel sword. If a player tries to craft anything other than two bronze swords, raise an exception with the cannot craft. Okay. So if two bronze swords are passed together, so if self dot sword type and type equals iron and other dot sword type equals iron, then what is it? Return a new sword instance. So return sword, that's going to be steel. Is that right? Two bronze swords. Whoops, bronze. So it's going to be iron. Bronze, else, elif, self. And then I'll just do the thing of like else. Raise exception. I'll copy that because I don't want to type it all out again. It's going to be iron. Return sword steel. Forgot a comma. Whoops. Hey. Easy peas. Operator overload review. As we discussed in the last assignment, operator overloading is the practice of defining custom behavior for standard Python operators. Here's a list of how operators translate into method names, which is the inverse of multiply. So multiplication is going to be division. True division. Overriding built-in methods. So we're almost at the end. Overriding built-in methods. Last but not least, let's take a look at some of the built-in methods we can override in Python. While there isn't a default behavior for the arithmetic operators like we just saw, there is a default behavior for print in a class. That's not super useful. Let's teach instances of our point object to print themselves using the str method, short for string. Let's us do just that. It takes no inputs but returns a string that will be printed to the console when someone passes an instance of the class to Python's print function. Bro, what? Yeah, I know, my head's in a bit of a twist now. Yeah, it's been a long day, Bassam. So I'm struggling to cognitively to keep going, but I just want to finish off this thing today because I don't want to creep into next week. So we get it done. Note the repr method works in a similar way. You'll see it from time to time. Assignment. Dragons are egotistical creatures. Let's give them a great format for announcing their presence in Age of Dragons. When print is called an instance of dragon, the string I am, blah, 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 the dragon, and it should be like that. So define string, and what is it? Return F string type thing, like that. Could be self dot name, self dot color, and that. Wishka. That's cool. Yeah, I completed the course, but not kind of completed yet because I need to finish these two challenges. Card class. Hopefully this won't take too long. Two left and we complete. We'll take a break from Age of Dragons to work on a simple deck of cards. Complete the card class. Define a constructor that takes the rank and suit as the parameters and sets rank, suit, rank index, and suit index instance variables. Okay, self dot rank. Rank suit and sets rank suit, rank index and suit index. So it's variables. You'll need the indexes of the ranks and suits to help you compare them against each other. Keep in mind that rank and suit are just strings within a list. All right. Okay. So self dot rank index equals ranks dot index of rank. Learned that trick before. And then this is going to be suit index suits. Suit. Overload the following comparison operators. Equals, greater than, ranking the cards. Okay. They're already given. A card is greater than another card if it has a higher rank. However, if the ranks are the same, card with the highest suit is greater than the other card. The same logic applies to lesson operator. Equal operator should check that the rank and suit are equal. So we just return so if self dot rank is equal to other dot rank and self dot suit is equal to other dot suit, then return what do we do? The suit. Lower the index to lower the rank of suit. True. Oops. Else. That's why. Okay, so less than, so if, we'll read it again. So let's start with the greater than because it's got the thing. So greater than another card if it has a higher rank. However, if the ranks are the same, a card with the highest suit is greater than the other card. So if self dot rank is equal to other dot rank then do this. Then we want to do if self dot rank index is hold on a sec, sorry, however the ranks are the same, the card with the highest suit index. So if the self dot card, if the other card has the right rank, so card with the highest suit greater than, so if the self suit score index is greater than other dot suit index, then return true. So if greater than, else return false. And then on this one it's L if self dot suit score index greater than other dot suit index, then return true, else return false. Same logic. Less than is less than is less than. Turn that. One pass, one fail. Which one failed? So ace of hearts, queen of hearts. So ace is higher, queen of hearts is higher. So expected equal is false. Yeah, they're not the same. Greater than is true. And less than is false. So greater than should be true. Whoops. Oh no. Self rank index. So rank index okay, so that's fine. So it never falls into that, which is what I expect. It should be here. So if suit index Greater than or equal to? Is that the... Nope. How far is it off? It's like way off. Okay. Oh, we're almost there. Come on. So what's wrong with the queen one? So it's not the same rank index, suit index. Oh, I'm a dummy. I don't need to do suit index. It needs to be rank index. Boom. This is a tired brain starting to kick in. This is the last one. God, we get through this. Yeah, thanks, Lee. Much appreciated. Oh, it's been a long day. Let's go. Let's go. Yeah. Okay. Let's get through this. It's nearly 11:30 here. Been up since 5:30 today. So let's see this through to the end and we'll call it quits. Let's extend our card logic into a fully fledged game of war. Okay. Assignment. The battle logic has already been implemented for you in the war. Oh, thank goodness. In the war class. However, for it to work, we need to complete the card game and war classes. Card game class constructor. So this one. Class is a base parent. Hold on a sec. Card game class is a parent class that will be used to implement specific types of card games. Initialize a deck instance variable into a deck of cards. So self dot we say deck equals deck of cards. Or do we need to pass that? I don't need to pass anything. Where's deck of cards? Nothing. We don't need to give anything. Okay, cool. Then that shuffle the deck. So deck of cards. I'm guessing there's just a shuffle method on it. Deck of cards, shuffle deck. So self dot deck dot shuffle. Shuffle deck, right. Oh, right, it's just complaining about these, right? Okay, we'll carry on. The play method just prints nothing to play because it's intended to be overridden by child classes. The war constructor. So inherits from card game. Yep, card game. Constructs. After all, it's a specific type of game, card game. It should call the card game constructor to initialize the deck. Call the card game constructor to initialize the deck. So super duper supercalifragilisticexpialidocious. To initialize the deck. Create a player one hand instance variable and set it to an empty list. Self dot play hand equals that. Player two hand like that. So the play method. Okay, so use the deal hand helper method in to use the deal hand helper method to deal 5 cards to one player. So if this is a card game, let's have a look at the card. Nope. Oh wait, hold on. The card game was up here, wasn't it? Play self, nothing to play. Deal hand. Card game. Deal hand. Let's do self dot deal hand, and then it'll be Hand to deal 5 cards to player 1. Hand, so it'd be self dot player hand, like that. I think it's like that. Do the same for player 2. Okay, once new hands have been dealt, call the battle method. Do battle. War class deal hand helper method. Use the deck's deal card method to deal. Deal hand, hold on a sec. Deal hand helper to method deal 5 cards, 1 play. Deal hand, hand. Oh, right, hold on. Use the to deal 5 cards to the hand. Deal hand. Card. Deck of cards. Great deck. Shuffle death. Deal card. Deal hand. So hand has got card game. Player hand. Self. 1 sec. Deal hand. Self hand. Hold on, where does card, deck of cards, where does that come into it? Oh, deck, right. Okay, I forgot about that. My bad. Okay, deck of cards is there, so deck, shuffle deck. So then we want to use deck. And what is it? Deal card self. Deal card. Okay, so we want to run that 5 times. Hold on. Who's it? Deal, return, self. Okay, right. I gotcha. So, deck dot. Forgot what it was. A deal card. Deal card. I want to be hand. Okay, right. Okay, gotcha. Okay, so hand dot append this like that. Is that right? Deck is not defined. Yeah, that's because it's self.deck. Self.deck. Let's just do that 5 times. 1, 3, 4, 5. Yes! So blimey. Crikey, yeah, we're at the end. Let's go. Can we get a let's go in the chat? Okay. We're done. Yeah, how do I... Yes, here we go. Here it is. Claim my 5,000... I'll open that actually as well. So claim my 5,000 XP. Woo! Yeah, a great introduction to OP and lots of practical examples that really cement the theory. And I'll put the same thing again. It's always 5-star. Submit a review. Boom. Let's go, GG, let's go. Now let's start the asteroid. Sheesh. No, not tonight. No. No, we're not doing that tonight. I would, but like, no, not tonight. It's half 11 where I am. Don't know where you guys are, but I hope you're enjoying it so far. Next week we'll do asteroids. I don't know how big that's going to be. It's going to be Pi game. It's going to be stuff I've not done before, so I have no idea. I'm just going to download that. Let's do a little bit of old sherry to LinkedIn. Let's do this. Yeah. So it's going to be Python. Object-oriented programming. Oops. Object-oriented programming. Yeah, I suppose it's those two, isn't it? So I'll add the media. This. Downloads. Download it twice somehow. Yeah, today. Suppose it's. Why? Alright, it's just override it. So, yeah, okay. Boom, shakalaka. Hold on. Is it called asteroids? Let me just double check that. I'll open these chats. Come on, let's open them. Open them. Hey. There it is. The asteroids. Python. OP. Sign some of these things on. There we go. Peas. Right, let's get this on. So we done that. We added it, and then we get it on X. Get it on X, boys. Now Wags Lane. Boot.dev. Boom, we done. We finished all the surplus things as well, so let's get this out of here. So we'll be back next week. I will look at my schedule and see if I'm going to be streaming Wednesday and Thursday next week. Most likely, yes. I don't think there's anything else interfering that week. So it's going to be 2 streams next week, back to normal, Wednesday and Thursday. Whoa, what a day. Crikey. We done. We finished object-oriented programming on Boot.dev. You were here, you saw it. It's a good course. It's been brilliant so far. I've been really enjoying it. Like I'm picking up, I'm filling in all the little gaps I've missed over the years or kind of glossed over or don't know as well as I should. And doing that, it's been great fun, great resource. Hope you had fun watching. I hope you got something out of it. Hope you, if you're looking to do the same thing, you go over to Boot.dev, get yourself thingied in. It's a great course so far. I'll be doing full review at the end and hopefully have like some affiliate link that can get you a discount and stuff like that, but we'll see. Thanks for coming. Thanks for watching. Have a good night. Have a great week as well.